Okay, can you hear me? Okay, can you hear me? So this is valid starting problem. The idea is that, let's say we have a few cities. What you want to find out is which city you can start from, right? Every city is going to have, so you have, these are the index of the cities, and the idea is that every city you are going to have some extra gallons, let's say like 2-3 seats, and yeah, what I'm doing, and you have some mile per gallons, and you also have the amount of distance, right? And always is going to be equivalent to the maximum, sorry, perfectly optimized, which means that at the end of the cycle journey you are going to have 0 miles per gallon, no matter where you start. What happens here is that what you want to do is to find out which is what's the index of the valid or a valid starting point, right? So you see at this, and the miles per gallon is 10, then the maximum amount will be something like 110, right? 110 is the maximum you can do. So let's say you say like I don't know, like 30, 50, like I have no idea what I'm doing. I don't know, 30, and you have to figure out which is the valid starting point. So one way to figure this out is by checking, by doing like a graph and saying relatively which is the lowest point, and then if you find the lowest point, then the next point is going to be the valid starting point, because you make sure that it is, if you grab like miles per gallon, you can find out which is the lowest point city remaining, then then the next one is going to be the valid starting point, because that's when you are going to have the least amount after traveling to there. That makes sense? Hopefully it does, because it doesn't make sense to me. Yeah, like, check on this. Why? Yeah, so weird. Let me check the video. Right, but why, if it's, for example, 3, why is 4, right? Why this is the starting valid point and not here? Does it make you think? Or maybe because going to this transition is impossible. I think that's why. Even if your gas going to be a lower point here, but you can make this transition, right? Because you're gonna have 0, at least in this example. There's going to be a lower point, and the idea is that for 4, yeah, that's the problem with this graph. Yeah, let's say we have a 25, 25. Right, something like this, right? Yeah, let's say you have this figure. What you want to find out is a fuel, and you say the fuel is I started with 5, right? So this will be like 1 2 1 0 3. What you want to find out is which is the lowest point. Imagine this is the lowest point. If you start, for example, from here, you're gonna have enough for here. You're gonna have 0 here. Then you're gonna have like plus 15, plus 25. Oh my god, 25 and 2. That's enough gallons? I don't think so. Okay, you're gonna have 5 gallons. You're gonna have 0 now. You add 1, so you have 10 miles remaining. And that's it. Alright, then you have like negative 5 remaining. How many? 0. Here you have negative 5, and from index 3 you're gonna have a plus 0, which is going to be like negative 15. Right. So this is the lowest point, right? Negative 15, and the next one is going to be completely exactly at 0, right? Because you're gonna add 3, which is going to be like 30, and then the minus 30 plus, right? You're gonna have 15, and that's going to be 0. So you want to have, the reason this is a starting point is because you can make this travel, I believe. You can make this travel, but from here the next one is what completes the cycle, right? So what you can say is that, yeah, so you can think like it's always like getting worse, way worse, but at this point it should recover everything. So that's why the almost last one, that's always the best one, right? So if we figure that out, we can say like validate density. So let's write the code here. Let's say the candidate city, and then we have the candidate for the candidate city, let's say 0, and then for this, right? Because we start. Oops. So what we can say is that we can create like on the data we charge for each one. I'll figure out like per distance is equals to we can say like const which is going to be this journey, right? So you calculate the previous fuel and the previous amount given, and that's when you figure out which is the current one, right? Current value over here. You multiply that by the miles per gallon, and then wait. Alexa, stop! Sorry, 6 a.m. What you want to do is the current fuel is less than the city, and the can fuel is equals to current fuel. Also the can city is equals to the index of the city, right? And this will be, and now we want to return the can city. Let's see. Preferably different. What? Reveal. Oh, there you go. Alright, that's it. 6 a.m.